Hello, welcome. My name is Dr. Brenda Reyes Ayala, and I am from the School of Library and Information Studies at the University of Alberta. Today, I have a presentation for you called A Grounded Theory of Information Quality for Web Archives, Dimensions, and Applications. This is a quick overview of what I'm going to be talking about. I'll be introducing it, the theory, then I'll talk about the methodology, then I'll talk about the different dimensions of my theory, and a conclusion. So the purpose of this particular research project was to build a theory of information quality for web archives that is grounded in human-centered data, and that was also independent of the technology that was used to create those web archives. And the main research question was, what is the human-centered definition of quality for web archives? Again, we talk about the human-centered definition, not necessarily the technological definition. So in order to arrive at this theory, I used the grounded theory methodology, which was first introduced by Barney Glaser and Anselm Strauss in their 1967 book, The Discovery of Grounded Theory. Now, Glaser and Strauss were sociologists, and remember that they developed this grounded theory methodology, or GT for short, which is a qualitative methodology. And GT is defined as the discovery of grounded theory from data systematically obtained and analyzed. So this is very much a bottom-up or inductive approach to creating theory. So when should GT be applied? Because it's not applicable to all situations. So GT is best applicable to those situations where a field or a discipline has a need for theoretical explanations, models, frameworks, and if it has very few or none at all, then this is a very rich area where GT is applicable. Also, when a human-centered approach is desired, as I've already said, GT is qualitative. So GT is heavily grounded in rich contextual data that is gathered from empirical research with people. So we're looking, we're focusing on what people think and what people say. We're not necessarily looking for things like crawler logs. So GT is actually quite different from traditional approaches to theory. You might be familiar with theories that are common in fields such as physics. And Glaser and Strauss call this the logical formal theory. And here's a table with a couple of highlights explaining the differences between the two. I'm not going to go over all of these, but I am going to highlight a few. So the first one is that traditionally we use statistical sampling, but in grounded theory you use theoretical sampling. That means that you only gather as much data as you need to generate the theory. At some point, the research will notice that she is actually not getting any new information from the data. She's just seeing the same information being repeated again and again. So that is a hint that you have reached something called saturation and that you need to stop and start creating the theory. The purpose of the traditional approach is to verify theory, but in grounded theory, our purpose is to generate the theory. Traditionally, in this approach, we want to establish the fact, but in grounded theory, you establish the structural boundaries of the fact. Now, traditionally, we have seen theory as a perfected product that is expected to change very little, but in grounded theory, theory is seen as an ever-developing entity that is arrived at through an iterative approach. Here's a snapshot of my process. The data that I use to generate this theory comes from the Internet Archive's Archive-It, or AIT, service, which is a subscription-based web archiving service that helps organizations build and manage their own web archives. I'm sure that many of you in IIPC are used to using Archive-It to manage your own web archive. So you're very, very likely, it's so popular that you're very likely to have some familiarity with it. So what I specifically focused on was AIT support tickets. And these are tickets that are submitted by AIT clients when they need help with their web archives. And they are read to and responded by AIT employees. For the purposes of this presentation, all of the data that I'm presenting here has been anonymized. So there are three core facets of information quality for web archives: correspondence, relevance, and archivability. And these are very much in order of importance, correspondence being the dominant one. And correspondence I define as the similarity between the original and the archive websites. Good correspondence requires equivalence or at least a close resemblance between the two. There are some subdimensions of correspondence. There's visual correspondence, interactional correspondence, and completeness. There is also the second most important dimension, which is relevance, which is the pertinence of the contents of an archive website to the original website. So the relevance comes in two subdimensions: topical and functional relevance. And the last one dimension is archivability, which are the intrinsic properties of a website that make it more difficult to archive. And this is a latent IQ dimension, as I will later show. Let's talk about the correspondence dimension. So visual correspondence is the similarity in appearance between the original website and the archive website. So when describing a quality problem, AIT clients will often compare the archive website to the original websites and note if there are any discrepancies, which they are quick to report. So visual correspondence problems are detected and arrived at through visual comparison. So some examples of visual correspondence in the data. In the first example, the client is saying, the look and feel are off. There are some things that are not there. And in example 2, the client is saying we're having trouble with our Facebook site captures not displaying properly or at all. Now, this is an example. This is an archive version of the University of North Texas campus map from 2004, almost unusable, because you just cannot see anything. So there's a lack of visual correspondence. It just doesn't look like the original. So it is by default a visual correspondence problem, among other things. So let's move on to our second subdimension, which is the interactional correspondence. And I define this as the degree to which a user's interaction with the archive website is similar to that of the original. So a problem occurs when a user's interaction with the archive website is different from that of the original, unexpected, or deficient. One common example is that video content in web archives is difficult to replay. It may have been captured, but when you click on the play button, it may not play. So that is an interactional correspondence problem. So sometimes this issue is caused by missing important files, but not always. So some examples of interactional correspondence problems. The first example, the interactive floor plan isn't working as it should be. The text should appear here, but it does not. And the second example, clicking on this link, view all comments, does not reveal a comment. So, the website does not behave as expected. So, another example of an interactional correspondence problem, again a map. Now, at first sight, we do see a visual correspondence problem because we are missing the image. But it is actually more than that, because in the original, this is a live application, and you can hover over specific buildings, you can click on things and get more information. But in the archive version of this, you cannot interact with this map anymore. So, this is an interactional correspondence problem as well as a visual one. So the third subdimension is completeness, which is the degree to which the archive website contains all of the components of the original. Occurs when the original website's content has not been captured or is not present in an archive. So this is a very common problem. We just have missing content that should have been captured that is not there. So an archive website can be perfectly complete, can have 100% completeness, but have low interactional correspondence problem. So some examples of completeness problems. On almost every blog, the Wayback Machine does not include the subsequent pages beyond the first. And in the second example, news pages are not being captured, but the actual articles that are listed and linked out are not. So just the missing content. So the most common way of doing this, seeing this, is that you simply navigate to a specific URL or web page in the Wayback Machine, in the web archive, and you see that you get sort of a message that is similar to this, saying, we haven't captured this, so it is missing from your web archive. But it is also viewable. If you look at the crawler logs from a capture, you can see that there might be some 404 errors where it just simply hasn't captured a specific component. So let's move on to relevance, and let's talk about topical relevance. And topical relevance is the relation between the topic of a file, web page, or website and the topic of the larger web archive to which it belongs. So this web archives, this theory, it is centered on kind of topical collections or topical web archives. Some examples here. The AIT client is saying we have a lot of things that are outside of collecting scope and that are problematic in content that are inside of our collection. The second example is that there's a lot of unrelated content, keyword, is being displayed. We're not supposed to have in our collection: Facebook, porn, dating sites, illegal content, and so on. And often clients are quick to ask to see if they can remove this type of content from their web archives. So relevance problems are often not visually apparent. A lot of these problems were detected by AIT clients when they were looking at the crawl logs, and they were seeing that, oh, we have all this content that we didn't want to capture, but that is somehow there. Another way of detecting it is it can manifest as size relevance problems when AIT clients see that there is too much content in their web archives. So an example, maybe the AIT client thought that this particular web archive should be 2 GB in size, but after it was created, we see that it was actually 10 GB. So we compare the size of the original to the size of the archive, and we see, okay, there's a discrepancy. Perhaps this is because we have captured a lot of unrelated content that we did not want. So some web pages also have what I call functional relevance. That means that they are not directly relevant to the topic of the web archive, but they are necessary for replaying the look and feel of the web archive. So some examples are cascading style sheets and JavaScript files. So as you know, these are technical files. Cascading style sheets control how a website will display, and JavaScript files control how a website interacts. So those are technical files that are not necessarily have any content that is related to the topic of the web archive at large, but they are absolutely necessary for having a good quality web archive. So I defined functional relevance as the relation between a file, web page, or website to accomplishing the goal of successfully replaying an archive website. So some examples of archivability is, so here you will see sometimes where it says C, that means it is the client speaking, and where you see AIT, it is the AIT employee speaking. So they're asking if we can capture this particular website, and the Archive It client is saying, well, it's going to be difficult because there's a lot of JavaScript. And in the second example, it is a similar situation. The AIT client is saying, well, this website has a lot of dynamic links, which are going to be a cause for trouble. So how is archivability problems in real life? Again, archivability is not often directly perceived, so you can't often assess it by visual inspection, so it is sometimes latent, and it is often detected by AIT employees instead of the AIT clients themselves. So the degree of archivability of a website can be estimated a priori by calculating how much of it is composed of dynamic content, such as JavaScript. And however, the true archivability of a website can only be determined a posteriori. So you can estimate how well do you think a website is archivable, how much a website is archivable, but you don't actually know until you actually go ahead and archive it. And it can change dramatically over time. Some websites become less archivable over time. And sometimes there is an increase in the quality of the software that we use, and we're able to deploy more advanced software to capture websites. So archivability may actually increase for some websites instead. So conclusions and future work. The theory presented here represents the majority of quality problems that were seen in topic center or event-driven web archives. If in the future new technologies were developed to capture websites more successfully, notions of correspondence, relevance, and archivability would still be important to the quality of web archives. Having clear concepts based on how experts perceive the issue of quality can lead to the successful creation of metrics, methods, and tools that will enable web archivists to measure the quality of their web archives, as you will see in the next presentation. Thank you for your time and support.